Hello chemistry fans, and welcome back to chemistry problem solving session here at the Academic Success Center on Broward College North Campus. I am your host, Dr. Russell Betts, and I'll be leading you through this question today. So let's jump right in. Chapter 7, Problem 5, balance the following chemical reactions. All right, this is something that we need to know how to do. It's not difficult. It's just a puzzle. Think of it as a little puzzle that you have to do. Don't think of it too much as a problem, because I don't want you to think of this as a challenging or a difficult thing to do. But it may take you a little bit of practice. So give yourself time to learn. All right, let's tackle the first one. FeCl3 cut. Let's try that again, sorry. Hello chemistry fans, and welcome back to chemistry problem solving session here at the Academic Success Center on Broward College North Campus. I am your host, Dr. Russell Betts, and I'll be leading you through this problem today. So without any further ado, let's jump in. Balance the following chemical reactions. All right, very standard question in chemistry, something we do a lot, and something that you'll get good at in the course of your studies. Very common exam question, so you're really going to want to learn how to do this. So let's look at the first one. Basically, when you're balancing chemical equations, you want the left side of the equation and the right side of the equation to have the same amount of each atom. That is to say, the iron on the left has to equal the iron on the right-hand side of the arrow. The chlorine on the left has to equal the chlorine on the right side of the arrow. They must be the same. If we take a look at this equation right now, we can see that on the left-hand side there's an element of iron, there's the element chlorine, and on the right side we have iron 3 chloride. So immediately by looking at it, you can see that there's 2 chlorines on the left and 3 chlorines on the right. That's not balanced. It's what they call out of balance. So here's a procedure you can use to help you remember how to do these questions, or help you to solve them. Take every element and write down, say anywhere, say right here, Fe and Cl. Now, on the left-hand side of the Fe and the Cl, write down how many of each element you have. So if you look on the left-hand side of the arrow here, we know we have 1 iron. 1. If we look on the left side of the arrow, we have 2 Cl. Okay? All we're doing is writing down what atoms we have and how many of them we have on each side of the arrow. Now we look on the right-hand side of the arrow, so now the numbers are going to go on the right-hand side of this little chart. We have 1 Fe. We have 1 molecule of iron 3 chloride, but we have 1 atom of Fe in that molecule. We also have 3 atoms of chlorine. We have 1 molecule of iron 3 chloride, but in that molecule we have 3 chlorines. We have to remember that. So we're not balanced. We have the irons are balanced. The irons look great, but the chlorine themselves are not balanced, so we have to balance them first. Now, notice we have an odd and an even number. We have a 2 and a 3. Whenever you see a situation like that, it's very simple to deal with. Basically, all you got to do is find the lowest common number they'll both divide into evenly. So what number can 2 and 3 divide into evenly? Well, 6. 6 divided by 2 is 3, and 6 divided by 3 is 2. So they're whole numbers. So that means we have to make the left-hand side 6 for the chlorine and the right-hand side 6 for the chlorine. So I want this side to be 6, and I want this side to be 6. Okay? I hope that wasn't confusing. I know it's a little bit weird, but this is how it has to be. Okay? Because I had an odd and an even number of chlorines, I want to find the nearest whole number they'll both divide into evenly, which happens to be 6. So I'm going to put a 2 right here. 2 times 3 is 6 chlorine. And I'm going to put a 3 right there. 3 times 2 is 6 chlorine. Now, I have 6 chlorine on the left side of the arrow and 6 chlorine on the right side of the arrow. The chlorines are balanced. The chlorines are balanced. Now, the trouble is, though, if you look on the right-hand side of the arrow, now you have 6 chlorine, but you no longer have 1 iron. You now have 2. So now my irons are out of whack. I have only 1 on the left. Well, we can fix that. Simply put a 2 right there. That gives me 2 iron right here. Now let's go over it again just to make sure we got it. 2 iron, 2 iron. 6 chlorine, 6 chlorine. This equation is now balanced. All right? So that's kind of how you should attack these questions. Now, let's look at the next equation. Again, let's do the same procedure we did before. Let's just pull out the atoms we have and figure out the answer. So we have iron. So there we go. Let's just write a little table. Iron and oxygen. All right. No big deal. There we go. Oops, I'm sorry. Not O2. Just O. Not O2, just O. So now we have 1 iron on the left and 2 oxygens on the left. All right. Look on the right. 2 irons on the right, 3 oxygens on the right. Okay? That's simply what we're starting with. That's nothing else, just what we're starting with. So again, we know we have to balance the equation. Now, let's just take a look. What do we got? Well, we have an odd and an even number again. Look at that. That happens quite a bit. So we have an even number of oxygens on the left and an odd number on the right. Well, just like we did for this equation up here when we had the same situation, an odd and an even number, let's take it to the nearest whole number that 2 and 3 will both divide into. And again, that's 6. So we need to make the left-hand side oxygen 6 and the right-hand side oxygen 6. How do we do that? Well, put a 2 right there. 2 times 3 is 6. And we're going to put a 3 right here. 3 times 2 is 6. So we balance the oxygens. Now, I'm doing this in marker because I've done them before. I know the answers are going to work out. When you're doing these kind of questions, you're going to want to do them in pencil because you may go down the wrong path. For example, you may have wanted to balance the iron first. Well, that may have got you there eventually, or it may have confused you. You may want to just erase and start again. So I tell students to always do these in pencil when you're beginning so that you can erase the coefficients. So now, we've balanced the oxygens, but now the irons are even more out of whack than they were before. 2 times 2 is not 2, it's actually now 4 irons on the right. 2 times 3 is 6 oxygen, 2 times 2 is 4 iron. But that's not a big deal. We simply put a 4 right there, and that gives us a 4 right here. Now, we think we're done, we think we're balanced, let's double check. There's no sense in not double checking because these are easy points on an exam. 4 iron, 4 iron, 6 oxygen, 6 oxygen. So that equation is now balanced. It wasn't that hard, I don't think. I think if you just follow the little chart here, or once you get good at it, you can not even do the chart. You can just go ahead and do it probably in your head once you get good at it. But give yourself time to get good at it. Don't just jump into it thinking you're going to be an expert right away, because you probably just won't be. And that's okay. That's okay. All right, last question. Ooh, a little more complicated. We've got a lot more atoms here. Well, the first thing I tell students to do whenever you see a question that looks a little bit complicated is don't panic. It's not as hard as you think. It never is. Just break the question down the way I've shown you. Now, this one is special because look at that. SO4. You might remember that from the polyatomics. That's a polyatomic ion. That's sulfate. So now, here's a great rule of thumb when you balance equations. When you see a polyatomic ion, balance it first. Always balance the polyatomic first. And, before I even get a little bit further ahead than that, treat the polyatomic as if it's one thing. Don't break it apart into sulfur and oxygen, because that you'll be here all day trying to balance it. Leave it as sulfate. It's sulfate here, and it's sulfate there. The sulfate didn't get destroyed, so leave it together. And here's what I mean. Maybe that was a little confusing. Here's what I mean. Let's break out all the atoms. So we have iron, bromine, oh, there's hydrogen, and sulfate. Now, that's what I meant by leave the polyatomic ion together. Sulfate. I didn't break it down into sulfur and oxygen. That would have been so much more difficult. Leave it as sulfate and count it as one unit. Now, on the left, we have 1 iron, 3 bromines, 2 hydrogens, and 1 SO4, 1 sulfate. Okay? Now, on the right, we have 2 irons. Now, look at this now. The sulfate is in parentheses with a 3 outside. That's 3 sulfate. 1 hydrogen and 1 bromine. Ooh, it looks a little scary, doesn't it? Looks a little scary. But don't get stressed out, don't get nervous. The rule is balance the polyatomic ion first. Okay? It almost, I'm going to say 99.9% of the time, it works perfectly that way. So I'm going to balance my polyatomic first. I have 3 on the right and only 1 on the left. I'm going to put a 3 right there. I balanced the polyatomic first. Now let's go over the entire equation again. I have 1 iron, 3 bromines. Now I have 6 hydrogen. 6 hydrogen. Uh-oh. That's a little scary. That's a little scary. And I have 3 sulfates. It's a little scary. The number got a little big. I'm not going to panic. Now, let's balance the hydrogen. I just screwed it up really bad. Let's balance it. So I'm going to put a 6 right here. I have 6 hydrogens on the left. I put a 6 right there. Now I have 6 hydrogens on the right. Again, let's go back to our table. Let's modify it because we made a change. Now we have to modify. 1 iron, 3 bromines, 6 hydrogen, 3 sulfates, 2 iron, 3 sulfates. Now we have 6 bromines and 6 hydrogen. Okay, this is starting to get a little weird, I know, for you guys. You guys are starting to stress a little bit. Don't. Just relax. The bromines are now even more out of whack than they were. Let's balance a bromine. I have 6 on the right and 3 on the left. Well, if we put a 2 right there, now we'll have 6 bromine on the left. So let's go through the entire equation again, changing the table as necessary. Now we have 2 iron on the left. Probably screwed up my iron real bad, I guess. 6 bromine, 6 hydrogen, 3 sulfates, 2 irons, 3 sulfates, 6 hydrogens, 6 bromines. Now let's look at the iron. Wait a minute. The iron's already balanced. Wow, that's pretty neat, huh? The iron just balanced itself. All I did was start with the sulfate. I balanced it first, and then I let the equation guide me into what was next. Balanced the sulfate, that messed up the hydrogen, so I balanced the hydrogen. That messed up the bromine, so I balanced the bromine, and the iron's balanced itself. Now, will it always work out like that where the last element balances itself? No, not always, but a lot of the times it will. So just follow that sequence. Always balance the polyatomic ion first. Now, that's the end of our discussion here on this problem. But I am going to say, if you have any problems with this, don't sit back on it. It's an important concept in organic chemistry. So please, or not just organic, but in all chemistry. So please make sure if you can't do it or you have any challenges with it to see a tutor here at the Academic Success Center. Come to my office hours. Do whatever it takes to get this straight. It's really not hard, but you do have to know how to do it. All right. Now with that, I wish you good luck and good chemistry.